Hello everyone, today I want to tell a story of pi. Nowadays, we all know what pi is, but the development of its concept and the determination of its accurate value have formed a very interesting piece of history in mathematics. So firstly, circle is one of the most common shapes in the nature, and the human beings have started to study it from very long time ago. For example, we could use two parameters to describe the circle. The first one is the diameter. So you can use a line to connect any 2 points on the circle. And you must be able to find the one with the longest distance, which is defined as the diameter. And also, you can travel on the circle from one point, okay, along it. And then when you come back to the same points, the distance you have traveled is called the perimeter. Sometimes it's also called circumference. And then people find when this circle is scaled up, for example, if the diameter is doubled from a simple measurement, they could determine that actually the perimeter is also doubled. So that means no matter how large or how small this circle, the ratio between the perimeter and the diameter is always a constant. And then they could just use this pi to define that ratio. So the pi is equal to perimeter divided by the diameter. However, it is very, very tricky to determine the accurate value of this pi. So people could estimate it's around 3, but it's very difficult to determine its accurate value. Maybe you can figure out some good idea. Okay, for example, if you find a round coin, for example, this €1 coin, and then you use a ruler, firstly, you can measure its diameter, and then you can just mark at one point of this coin and start here. You can roll this coin across this ruler until this mark returns to the ruler, and then you can determine its perimeter. And then you can just use this perimeter to be divided by the measured diameter and to determine its pi value. I have to say you have done a good job, but please bear in mind that the ruler carries some intrinsic errors with it, and it is not possible to measure any distance or length 100% accurate. Also, I have to say the mathematicians, they are a special group of professionalists. They don't like this type of the physical measurements. They just want to use the pen and paper to pursue some calculation with 100% accuracy. Okay, so in this story, I just want to highlight the contribution from a Chinese mathematician called Zhu Chungzhi. He lived in the years around 400 to 500 AD. So here is his portrait on a Chinese stamp because this is the only copyright-free picture I can find from the internet. So before Zhu's time, the pi value has been determined up to 2 decimal places accurately, something like 3.14, okay? And his approach was based on the area of the circle instead of its perimeter, because at that time, people have already established the relationship between the area and the radius or diameter. So for example, the area is equal to pi times the radius square. So that means if you know the radius and if you can calculate the area of this circle accurately, you can still get a very good pi value. There's no problem with that. So here, I just want to introduce Zhu Chungzhi's strategy in working out the area of the circle. So firstly, he drew a square inside this circle. And at that time, because of the advance of the geometry, so if he knows that this diagonal of this square is equal to the diameter of this circle, okay, from this diagonal, he could accurately calculate the area of this square, even if it involves something like square root of 2. Okay, so don't worry about it. So he could calculate the area of this square very accurately. And then he just used this area of the square to represent the area of the circle and to calculate this pi value. You must argue at this point. There must be too much error because this square is so much smaller than the circle. Yeah, I agree with you, but we have to be patient here. This is only the very first step of his approach. So from this square, he drew another octagon, and then again, he could calculate the area of this octagon very accurately, and then he just used the area of this octagon to represent the area of the circle. Okay, so even there is still lots of errors here, but compared with the square, this is much closer. Okay, so you just imagine he could keep doing like this, and then he could just draw another 16-sided polygon to represent the area of the circle, and he could calculate the area of this 16-sided polygon very accurately. And then he just kept doing this again and again until, to our very big surprise, so he has approximated the circle with a 24,576-sided polygon. So he must have drawn a super large circle and put in enormous effort. And finally, he could determine the pi value using this fraction, which is 355 divided by 113. And also he could determine the pi value, which is between 3.1415926 and 3.1415927. Okay, so only the last digits, 6 and 7 from the estimation, and the 6 decimal places, 141592, are absolutely accurate. So compared to the previous value, this is a major breakthrough. So here we just want to learn the strategy of Zhu's approach. So we understand it is not possible to calculate the area of the circle. However, we can use the polygon to approximate it. So if this polygon has enough size, for example, more than 24,000 size, so this polygon actually is extremely close to the circle. So its area is extremely close to the area of the circle, which can be used to calculate the pi value. So in this diagram, it shows the number of decimal digits of the pi value in the history against the year. So you can see at the year 480, so there is a jump here by about 3 or 4 decimal places. So this was the breakthrough from Zhu Chongzhi. And actually, his record was kept for more than 900 years until the year 1400. Okay, so in the year 1400, there was another Indian mathematician called Madhava. He discovered an infinite series which could be used to calculate the pi value. So that series can be written as 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus 1 over 9 minus 1 over 11 plus 1 over 13 minus 1 over 15. Okay, so you can just keep doing like this. It's formed by a series of the fractions based on the odd number with plus and minus alternately. So if you just include more and more fractions, and then this calculation results will be closer and closer to the value of the pi over 4. Okay, so Madhava just spent lots of time to calculate this using many fractions, and then he determined the pi value with accurate 11 to 12 decimal places. Okay, so here is another major breakthrough. So following that, of course, many more mathematicians just keep improving this accuracy of the pi value until 1950. So you can see before 1950, the number of decimal digits of the pi value is about several hundred. Okay. However, after this year, there was an explosive increase in the decimal places. Okay, you can think about what was the reason behind this revolution. So it was because of the invention of the computer. Okay, because the computer was invented in 1946. And then there was an updated infinite series to calculate pi value. So this is based on this summation operator. I is from 0 to infinite. So basically here you just bring in the I value, for example 0, into this expression and calculate the value, and then put I equal to 1 inside and calculate its value, and then I equals 2, 3, 4, 5, and put in. And then you just add all of them together. So you will see the more I values you put in, this summation result will be closer to the actual pi value. Okay, of course, here I is from 0 to infinite, so this calculation can never be ended. But just the more I values you put in, the more accurate the pi value we can calculate. So of course, with the advance of the computer technology, people can just determine the pi value with more and more decimal places. So nowadays, I'm sure they can easily reach something like 10 to the power 14 or even 10 to the power 15 decimal places for the pi value. But I have to say, the calculation of the pi value is not really useful. Even you calculate the pi value with 10 to the power 20 decimal places, it's not really useful to calculate the perimeter or area of the circle. So instead, this can be used to test the performance of the CPU. Okay, so for example, if there is one CPU, you can ask it to spend 1 second time to calculate the pi value and see how many digits or how many decimal places it can accurately determine. So this just reflects how fast it is. Anyway, the history of determination of the pi value is an amazing story. And if you are interested in this area, you can do some further reading. For example, there are 2 web pages I listed here. There could be many more. Okay, thank you very much.